Good afternoon, everybody. We are Group 9, and we modeled parts from Engine 13. I'm Jared Bennett, and I'll be talking about the connecting rod. Frank will be talking about the camshaft, and Matthew will be talking about the piston and gudgeon pin. So I did the connecting rod, and it includes a bearing cap and connecting rod, just like the rod itself. It functions as a link between the piston and the crankshaft. It contains a small hole on one end and a larger hole on the other end. It transfers reciprocating motion from the piston and into rotary motion to the crankshaft. So for the modeling, I initially started out with this small extrude right here. I went to my main sketch and boss extruded many parts from my main sketch so that I wouldn't have to cut extrude as much. You see I started with a circle here, and then I added this right here to the shaft that was a different thickness than my circle itself. Well, that's the small circle that connects to the crankshaft. So as you see here, I also extruded a little more things like up in here, over there, as you can see the gap that I filled here. And I also filled the gap inside of the connecting rod. These were all different thicknesses, and so I could have made a solid part, but instead I decided to just boss extrude the whole entire thing. So here, the small circle on the back end of the connecting rod was at an angle, and I made a plane 30 degrees, and I made a plane and sketched a rectangle and cut extruded. This is my first cut extrude, and cut extruded both sides of the circle. And as you see on this side, I put a little more details, some fillets, and I also added the boss extrude here and a cut extrude up here, these two circles here, and mirrored this boss extrude onto the other side. So here I added more fillets. There was a lot of fillets. And then also here, as you can see on the very top, this was my next boss extrude to get the hole that connects up there. And then once I did that, I did some fillets and rounded it off to be more spherical. And then I added my 3 holes where the pins would go. And so this is the finished product of the connecting rod. Like I said, there's lots of fillets, so I added more fillets and cleaned it up a bit, and it turned out pretty good. I see the isometric view and different views that I put in. You see the holes here, and also the feature right here on the bottom, there's a conical hole feature to where the hole went wider for the screw. And then here's another product, so looking at the right view and then compared to mine. Alright, so the bearing cap modeling, this connects to the connecting rod. I started off just with initial loop right here, and then just kind of, like I said, I just kind of extruded off my main sketch, kind of did the same process for my bearing cap. And here, I extruded a few more features, and then I cut extruded 2 holes on both sides. They were the same size, similarly. And so here, I have a cut extrude here. There's a lot of more cut extruding on this one, I believe, than the actual connecting rod. And then put some depth right there where I cut extruded, and then added some more fillets. And so the finished product, as you did see on the other slide, this was the one that I was initially in the view that I was working on. I also had to do it on the same on this side where I cut extruded and made it kind of like a circle extrude, cut extrude. But it's actually different on this side than it was on this one. And so I just had to tinker with that and make sure that my measurements were right whenever I was doing those extrudes. And then make sure that also my holes lined up correctly. And so this is the assembly of the 2 parts together. It did fit correctly, thank goodness. And as you can see, it just connected right here where the opening, where the teeth was, it connected there. And so our prototype versus original, we decided to do ribs inside of the shaft to give it a little more strength not more, well, it still would have the same strength, but it would be lighter. So there's a lighter connecting rod, but it still had the strength due to like tensile and compressive forces coming in. We didn't want to make it just completely hollow because we feel that would make it fail since it's made out of aluminum. And then this is the prototype installed in the engine where we are taking measurements. The prototype did fit. So, all right, now I'll pass it to Frank to talk about the camshaft.
Thank you. Now I'm going to talk about camshaft, which is basically the component that is going to transform the rotary motion into linear motion. I first started by doing the central rod and the pin, which are just basically to extrude two things. But in order to do this one, I actually used a revolve because I felt that it was easier in order to avoid using reference planes. And the pin was fairly simple, just extrude and extrude with the distances and measurements that I took before. Now, I think that the hard part was trying to do this one because for the main gear, I had to use the tool bots, with which I did the gear first, and then I started cutting parts off so it will fit the model that we have. When doing using the toolbots, I had to go into the equations that we're doing in the component and mess around with those in order to get the correct diameter, and that's it with that one. Then I used a circular palm to cut these parts in there, and a mirror in order to do this small part here. After that, it was just a small strut to get the other part that is in there. Now, this one is fairly simple too. It's just a strutted part in which I firstly do the first geometric sample that you see there. I extrude it from there. Then I use a reference plane, and I cut from there. Another reference plane in order to extrude the small part that you see here. And I use a mirror in order to create the same geometry from the top and the bottom. Then I use an angle for it to be the correct position. Now the bracket, I just created a sketch for the right side. I extrude it and then I do the cutting, trying to get off all this part from there. And then I use a revolve cut to get this part. Then another reference planes to start doing that small portion there and this kind of hook. Now, from the assembly, there were a lot of mates that need to be done in this one. There was some distant mates between the gear and the shaft or the cam. Then there were constant mates between the planes in order for them to stay together and they have a rotary motion together. There was another distant mate between the pin and the gear, but that was fairly everything there. However, in order to have the correct motion or to simulate that in SolidWorks, we needed to use a mechanical mate in which you have to use two axes in order for them to get together and get a really good measurements in order to get the correct distance that is between the two teeth in there. And that's it. And this is an isometric view of how it will look. Now I'm going to pass it to Matthew that is going to talk about the piston and the other part.
So my name is Matthew+Stuart, and I had the piston and gudgeon pin. And how I started off with doing the pin was I sketched the profile of the cylinder, because the piston is just a cylinder with details on the outside and also on the inside. So I started off with a shape, with the sketch, with the three ribs that were for the rings, and then I revolve extruded it, as you'll see in the next slide, to form half of the piston. And by doing this, I was able to do all the details on one half, so that then I could just mirror it and get the same exact details on both sides. So after I did half the revolve, I made a plane and cut a flat surface, so I could then start building some of the extrudes off of it. And after I cut that, I then built the larger center lobe, which holds the circles for the pin to rest in. And then after that, I did these extrudes over here for the lobes on the side. And then after that, I moved on to start forming the bottom chin of the piston, and I started this by doing a block, and then going in and cutting that block down to the right radius. And then after I did that, I went back and filleted it, and also I cut this trapezoidal shape through the pin for the design of the piston. After this, I was able to mirror the other side so I would have identical halves. And after doing this, I then had to go back and do the different holes. Now each side had different hole diameters based on which side the pin would enter through. And also on one half, the pin had an inner ring around it, as you can see here, that was a different diameter. Also on one side, you had the hole for where the locking mechanism goes to lock the pin into place. And also you have the timing mark at the top of the piston. To do this, it took a good bit of planes to get that timing mark on correctly, as well as other things. To do the pin, I did a similar thing. I made a sketch of the profile of the cylinder, and then after that I revolved that to get the final cylindrical shape. And then by doing this, I was able to avoid having to do chamfers because I designed the chamfers into the sketch. And finally, here's the assembly together with the pin and the piston. And as you can see, the piston enters the pin through the side with the locking hole, and it rests upon, it has a concentric mate within the holes inside the lobes, and then has a coincident mate with this ring here on the inside that sticks out from the hole to block the pin going all the way through. And so the top view of top is what it would look like completely assembled. So thank you all for y'all's attention today. Group, me, Jared, and Frank, we appreciate y'all's